Welcome to today's presentation. This video is about equation of a circle. A circle center C 5, 5 passes through points A 1, 3 and B A 9. Find the equation of the circle and hence the possible values of A. So first of all, let us begin by sketching the circle. The circle is of center C given by the coordinates 5, 5. And then there are 2 points on the circumference. We are told the circle passes through point A, which is 1, 3, and point B, which is A, 9. Before we use the information on this circle, I want us to recall that the general equation of a circle is given by x minus A squared plus y minus B squared is equal to R squared, where the center is given by the coordinates A, B, and the radius of the circle, the radius is R. The first thing in this equation I want us to determine is the radius of the circle, which from what we are given here, we can obtain by simply getting the modulus of AC. Remember, AC and CB are both the radius of the circle. So this is R. So I want to use AC because for both coordinates, we know the values. So AC as a vector will be obtained as position vector of C minus position vector of A, that is OC minus OA. But OC is given us, so we have point C arranged in vertical alignment, that is as a column vector, that is 5, 5, and OA is 1, 3, that is as a column vector. When we get the difference, this becomes 4, 2. Now, the modulus of AC, that will be the radius. The radius is just the modulus of AC, or the length of AC, which is obtained as the square root of the sum of the squares of these elements. So we have 4 squared plus 2 squared. This is root 20, 16 plus 4. So if R is root 20, getting back to our equation, we have x minus A squared plus y minus B squared is equal to R squared. And also we need to remember that the center is 5, 5. That means A is 5, B is 5. So let's do our substitutions. So in this general equation for a circle, we'll have x minus A we already determined as 5, squared, plus y minus B is also 5, squared, is equal to R squared. So we'll square root 20, and that simply gives us 20. Once again, these 5 and 5 are the coordinates of the center. Remember the center, AB, if we relate it to this, AB in this equation, according to the equation, center C is 5, 5. So the value of A is 5, the value of B is 5, so that's what we've substituted here. Now, X and Y are the coordinates of any point at the circumference. Like if you consider, if you consider point B, we have A9, so X is A, Y is 9. So if we may relate it that way, XY is equal to A comma 9. That is for point B. So we're going to substitute this in this equation again, so that in place of x we'll have a, and in place of y we'll have 9. So a minus 5 squared plus 9 minus 5 squared is equal to 20. So applying the quadratic identity for this first part, the quadratic identity a minus b squared is equal to a squared minus 2ab plus b squared. We can just use this identity here to expand this first part. So a here corresponds to a, so we square a squared minus 2ab, that is 2 times a times 5. Our b is 5 according to this expression, or rather this equation here. B here is 5, so 2 times a times b, that is 2 times a times 5, which is 10a, and then plus b squared, so that is 5 squared, which is 25. And then we'll have to add that to 9 minus 5 is 4, 4 squared is 16. The right hand side we have 20. We can simplify this further. 25 plus 16 is 41. 20 comes this side, so that we subtract 41 minus 20, and that is 21. So we can have a squared minus 10a plus 21. And then the right hand side, we now have 0. The task that remains is to solve for a from this quadratic equation. Now you can use quadratic formula, the factor method, whichever one that is easier for you. So I'm going to use the factor method here. So we're going to look for two factors such that their product is equivalent to the product of coefficient of a squared here and constant term 21. So 1 times 21, which is positive 21. And then their sum should be equivalent to the coefficient in the middle part, which is negative 10. Now the two factors are negative 3 and negative 7. Add them, you get negative 10. Multiply them, you get 21. Now we are going to use negative 3 and negative 7 to split the middle part of this equation. So we have a squared minus 3a minus 7a. So minus 3 and minus 7a have replaced negative 10a, and then plus 21 is equal to 0. So we are going to factorize this by pairing. So we pair this and pair this other part and factorize. So common factor for this first part is a. So a out, in the bracket we have a minus 3. And then here 7 is common, so negative 7 common. Factor it out, we have a minus 3. And then we equate to 0. Well, a minus 3 is common. Factoring it out again, we have a minus 3. And then in the brackets, we have a minus 7. And then the right hand side, we have 0. From here, we can say a minus 3 is equal to 0. And therefore, 3 crossing, we have a minus 3 is 0. 3 coming to this side means a is positive 3. Applying the same to a minus 7. A minus 7 is 0. And therefore, 7 crossing, we have a as 7. So a is 3 and a is 7. So a can either be 3 or 7. And those are the possible values of a, just as had been desired in the question. And with this, we come to the end of the solution to this problem. Thank you for watching. Bye.